Hey guys, welcome back. So today we are going to work on reducing some complex fractions. So there are a couple different ways to do this, but they all share one common goal, which is to cancel out any common factors in the numerator and the denominator. So let's go ahead and take a look at the first one so I can walk you through the steps and show you how to do this. So the first one gives us the fraction of 13 over 52. So we kind of want to look at the numerator and analyze its factors and then do the same for the denominator. So in this case, the numerator 13 is prime, so we know its only factors are 1 and 13. We can't do anything else to it. However, in the bottom, we notice that we at least know that 2 is a factor because 52 is even. So let's go ahead and start by pulling that out. So in the top, we're going to have 13. In the bottom, we're going to factor out a 2, and we're going to be left with 26, because 2 times 26 is 52. Now, let's go ahead and do that one more time, because we see that 26 is still even, so we know that we can pull out another 2. So from there, we're going to get 13 over 2 times 13. So now we see something very interesting. We notice that the numerator and the denominator have a common factor of 13, and that means that we can actually cancel those out. So if we cancel this and cancel this, they basically each become a 1, and this gives us 1 over 2 times 2, which is equal to 1 over 4. So one thing I want to note quickly before moving on is that I knew to stop here when I got it into 2 times 13, because everything in the denominator was prime. 2, the only factors are 1 and 2, same thing here, and then 13, again, it's only 1 and 13. So that's when you can go ahead and start canceling out your factors. So simplifying 13 over 52, we get 1 in 4. So now let's go ahead and look at our second one. So our second one says 26 over 65. Sorry, I lost it in all those numbers over there. Okay, so from here, I'm going to do the same exact thing. So I notice that 26 is going to be 2 times 13, and I'm done there because both of these numbers are prime. And then in the bottom, I'm going to notice that 5 ends in a 5, so we know it's divisible by 5. So I'll start with that. So that's going to be 5 times 13. There we go. And then going from there, we are going to be able to cancel out this 13 and this 13, because again, both of these factors are prime. So now when we simplify this fraction, it's going to simply be 2 over 5, and that's our final answer. Now let's go ahead and take a look at number 3. That says, I believe that's a plus sign in there, so that would be 3 plus 6 over 3 plus 9. So I believe they gave you this question as kind of a trick question because they wanted to see if you would just cancel out these 3's, but it's important to note that you cannot cancel out those 3's because they're not being multiplied. If the question was instead, here let me write it in blue, if the question instead was 3 times 6 over 3 times 9, that would be a different story. Then you could cancel this 3, and this could even actually be further reduced, but since that's not the question, I won't even go there. So going back to the actual question, first we have to add 3 and 6 for the numerator, and we're going to get 9. And then in the denominator, we're going to do the same thing, but we're going to get 12. Now we can break each one of these down into its factors. So 9 is equal to 3 times 3, and 12 is divisible by 2, but it's also divisible by 3, so I'm just going to choose 3 because it's also a factor in the top. So here we're going to get 3 times 4. So now that you guys have kind of gotten the hang of it, I'm going to kind of skip a step here because I could break 4 down into 2 and 2, but because there isn't any 2's in the numerator, that's kind of an unnecessary step because eventually I would just have to multiply them back together. So here, instead, I'm going to go ahead and just cancel this 3 with this 3, and this is going to become 3 over 4. And that is it. Awesome, so let's move on to number 4. Okay, so for number 4, we have 6axy over 15by. So now the first thing I'm going to do is focus on the constants, so the 6 and the 15. So 6 is equal to 3 times 2, and then in the numerator it's going to be times a times x times y. So I just spread these out. And then in the denominator, 15 is equal to 3 times 5. So I'm going to write 3 times 5 times b times y. So now I see that there are actually two factors in common to both the numerator and the denominator. There's this set here, and there's these y's here. So these can be canceled, and these can be canceled. So now, putting it all together in the numerator, we are going to have 2ax over 5b. And that there is our final answer. Okay, let me erase this page quickly, and then we will start on number 5. Okay, that's close enough. There's still a little bit there, but that's okay. Here, there we go. Okay, so for number 5, we have 14x plus 7y over 7y. So again, you might be tempted to cancel the 7y's out, but you cannot do that unless they were being multiplied. Unless in the numerator it was 14x times 7y, then you could cancel them. But whenever they're being added, you can't cancel. But what we can do is when we look at the numerator, we notice that 14 is 7 times 2. So that is going to be, we can write it like this, 7 times 2 times x plus 7 times y. And these are grouped together, and these are grouped together. All over 7y. So in the numerator, again, since there's a common 7 here and a common 7 here, we can factor it out front and write it like this. 7 times 2x plus y. All over 7y. And we can do that because if we were to multiply the 7 back in, or distribute it back in, 7 times 2x is our original 14x, and then 7 times y is our original 7y. So now what we have is we have 7 times 2x plus y over 7 times y, and again we have this common 7 here. We can cancel it out, and then we are left with 2 times x plus y over y, and that there is our final answer. Okay, let's take a look at number 6. So number 6 says 5a plus b over 5a plus c equals what? So in this case, it's actually very interesting, but the numerator doesn't have any common factors. There's nothing that we could bring out front, and the same thing is true of the denominator. So here, we actually can't reduce this. This fraction is reduced. So in this case, we would just write it as is, and that would be our answer. So let's take a look at number 7. So for number 7, we have x minus 3 over 3 minus x. So hopefully you guys noticed that these look pretty similar. You have an x and a 3. The only difference is the signs are opposite. So in the numerator you have a positive x, and in the denominator you have a negative x. Likewise, in the numerator you have a negative 3, and the denominator you have a positive 3. So that should be a tip that you're going to want to factor out a negative 1. So in this case, I'm going to leave the numerator as is, but in the denominator, I'm going to factor out a negative 1. So doing that is basically going to flip these signs. So I'm going to get a negative 3 plus x. And again, if you're not sure, you can always distribute this back through to prove to yourself that it is in fact equal to what we had here. So I'm just going to go ahead and rewrite this. So we're going to have x minus 3 over negative 1 times x minus 3. There, I just wrote the x first, followed by the 3. Now we have a common term. We have this x minus 3 here and this x minus 3 here. So that gives us a 1 over negative 1, which is just equal to negative 1. So that would be our answer for number 7. Now, last but not least, let me erase the screen one more time. Let's see. There we go. Okay, so for number 8, we have 4 times x plus 2 times x minus 3 over x minus 3 times x minus 2. So in this case, I'm going to notice that they have a common x minus 3 term, so I'm going to go ahead and just cancel that out now. And let's go ahead and keep going just for the sake of argument. You're not actually going to be able to simplify any further, but let's say if you weren't sure and you wanted to distribute this 4, you would get a 4x plus 8 over x minus 2. And again, there's nothing else that there are no other factors that we could factor out. So from here, our final answer would just be this here. All right, well, I hope that was helpful. I will leave the link to the assignment that I found these problems on in the description box. If you enjoyed this video, please like it. I would really appreciate it, and good luck studying.